Your Next.js website is slow, and it usually comes down to one thing. You are not using partial pre-rendering. Most developers only know two rendering strategies: static site generation, lightning fast but pretty rigid, and server-side rendering, flexible but slow since every request has to be processed at runtime. Partial pre-rendering is the best of both worlds. It lets you serve a page instantly as static content while sprinkling in dynamic content when you need it. And today I will show you what PPR is, how it works, and more importantly, how to implement it. So without any further ado, let's go! Alright, so before we now dive into PPR, partial pre-rendering, we have to first of all understand what rendering types we have access to. And the first one is SSG, static site generation. This means the HTML is generated at build time and is reused for every request. So let's imagine the following. You finally finished building your beautiful website. In this case, this is my website, and now you want to deploy it. You either use Vercel or any other host, and what does your host do? Well, your host will run one command, next build. And next build will build your application for a production use case. And the thing is, Next.js is quite smart. So let's imagine the following. You have some sort of about route, and inside of there, or let's say this right here, I have an ultimate Next.js route, and inside of here I don't fetch any data. This means in theory this can be statically rendered, right? And that's exactly what Next.js will see. It will see right here, the user does not fetch any data. How about we render it statically? So how does this work? Good question. Next.js will generate the HTML at build time, so while the application is built. And then this HTML will be put into a CDN, which is distributed globally. This means once a user makes a request to your website from, let's say, Mexico, the website or the HTML will also be served from Mexico because the CDN network probably has a server in Mexico. So this means nearest to you. And then this build is also reused for every request. This is the workflow. A user makes a request to your website. Instead of hitting the origin server in, let's say, the US, instead the request will be funneled through the CDN, which means the response is almost instant. Let me again show you my website. So if I do a hard refresh, I literally get the response instantly. There's no delay and there's almost no runtime logic. If I open the inspector and go to the network and again do a hard refresh, I get all of my responses. And if I look at the document, you will see something interesting. I have response headers, and here there's a header called X Vercel cache, and this is a hit. This means this page is statically rendered. The HTML got generated at build time and then served from a CDN. And again, this means everything is distributed globally on the edge. Let's maybe also look at a real example together. So right here I created a demo website, which is quite interesting. So I have a few sections. So first of all, static content. This is just HTML, nothing else. Then I have an authentication section. Inside of here, in theory, I fetch user data, dynamic user content. Right here I again just fetch user data, and then I have this section where I fetch data for the Next.js repo. So I get the stars and the forks. Let's look at the code quickly. So this is the page.tsx, and I have quite a bit of code right here, but don't get confused. It's not complicated at all. So first of all, I have this async function, or in general, I have three async functions and a export default function. So the first async function gets the user data. So this section right here, dynamic user content. I first of all get user data with my email, and then I also get a quote from GitHub. I hit the GitHub API and then it returns some sort of quote, and I rendered right here GitHub Zen. Then I have another async function, for example, for the Next.js repo data. I again use the API, I get my data and I rendered. Now here's something that many people get confused by. They think that whenever you fetch data, you can't use SSG SSG anymore. This is not true actually. So as you see right here, I fetch data. I use fetch, the fetch API. Nevertheless, since I don't add any arguments right here, cache arguments, this will actually be cached. Let me show it to you. If I open my terminal and run npm run build, so again, this is what Vercel will run whenever you build your application or deploy it. And here we see something interesting. So this is like a table with all of the routes, and the index page has the circle, and the circle stands for pre-rendered as static content. So even though I fetch data, this is still pre-rendered. This is still SSG. What this means is Next.js will literally just build your application. At build time, it will fetch the data and then generate the HTML. So this means whenever, for example, data updates for this repo, we won't get notified because it's not dynamic. And that's a big problem with SSG. So what could the solution be to get dynamic data? Because again, SSG is super fast. The response is instant. Nevertheless, it's not dynamic and it's not flexible. Well, the solution is server-side rendering, or in short, SSR. The HTML is generated on every request. So with SSG, the build got reused for every request. But now we will generate the HTML on every request. There's no sharing. So how does the workflow look like? Well, our user makes a request, but now there's no CDN in the middle anymore. Instead, we will make a request to the origin server. So for example, my origin server is US East 2, if I'm not mistaken. For you, it could be Frankfurt or something like that. We hit the server generates the HTML at runtime, and then this HTML is served and we get the website. And this is done for every request. So every user has to do the same thing. Hit the origin server, get the response, and then we see the HTML, or in other words, the website. Now this isn't great. This is not very fast, and actually this can be a huge blocker. What do I mean by that? Well, let me go to my dynamic route. So if I go to a tutorial, I have a loading state. That's because this is server rendered. If I open my inspector and go to the network and do a hard refresh, it fetches all of my data. And if I go to my document and scroll to the bottom, the Vercel cache is a miss. This hasn't been cached. I now hit my origin server and it generated everything at runtime, no build time at all. And now what do I mean with this can be a huge blocker? Good question. If I make my website or my network very, very slow and do a hard refresh, I have a blocking event. In theory right now, I won't see anything. Let me open this route in a new incognito tab. You see it takes a bit, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, and then I only get my data. So this is a huge blocking event. My God, it's so slow. Now I just got my data. And now I know exactly what you want to ask me. Hey Jan, so now we know what SSG is and we also know what SSR is. So what's PPR and how do we implement it? Well, before we come to PPR, partial pre-rendering, we have to first of all implement SSR, because for PPR to work, you have to first of all SSR your page. This means let's go back to the code example, and as you all know, we fetch our data 3 times because we have 3 async functions. So let's start with the first one. So inside of here, I want to get user data, and also I use this GitHub API to get a random quote. So first of all, we want to make sure that this quote is not cached anymore. How do we do that? Good question. So Next.js, the team actually updated or adapted the fetch a bit, the API, and they extended it with this cache property. And here I have a few options: default, force cache, and a few other things. Now in this case, I want to say no store. This means this whole request won't be cached at all. If I leave it as default, then it will be the default, which means this request will be cached. So I will just copy this property, cache no store, and I will paste it inside of here. So above the headers, cache no store. And for this async function, I don't fetch any data specifically, so I don't use the fetch API, which means this is already finished. So we are finished with the fetch API. We now make sure that these 2 fetch calls are not cached. Nevertheless, the user session is still not dynamic, because right here I just hard-coded the user with the name, email and stuff like that, but this does not work. We want to get the real user session somehow. So what does this mean? Well, it's time to implement authentication. And for that, we will use Kind in this video. Kind is the sponsor of this video and my favorite auth solution. They offer everything from basic authentication to advanced authorization. And they recently even released billing, which makes it very easy to monetize your ideas with game-changing billing tools. And soon I will release a huge video featuring billing. Stay tuned. B2B organizations AI, super cool. But let's get back to this video. And right now I want to implement authentication very quickly in 1 minute or so. And the first step is to first of all sign in. Once signed in, you want to create a new business with a business name, kind domain, number of employees and region. Then as you see right here, my business has been created, which means I can open it. Now we get an onboarding guide. So I want to use Kind with my existing code base. Then I want to integrate Kind with my Next.js code base. And also I want to allow my users to sign in with email, Google, and let's say GitHub. Why not? And now we're almost finished, and the last step is to connect our Next.js codebase to Kind. So I will click on connect, and here we get a little quick start guide. So what I will do is quickly follow this quick start guide. You will also do it, and once finished, I will come back. I now implemented Kind and also I updated the environment variable, so one specific environment variable, and this is the login redirect URL. This means once a user successfully logs in, I will redirect the user to the index page. And now we want to also allow the user to register to sign in, which means we have to redirect the user to the hosted authentication page. Doing that is actually very simple. First of all, we can delete our constant user because now we will get our real user. And then here in the auth section, we want to do two things. First of all, we want to get the user session, and also instead of using these A tags and redirecting the user nowhere, we want to redirect the user to the hosted authentication page. So let's start with the second step. Here in the quick start guide, they have a section on how to redirect the user. So they offer two components, the login link and register link components, which can be used to start the auth flow. And that's exactly what we want to do. So I can copy the import statement. I will paste it on the top. And then instead of using the A tag, I can get the login link component. Instead of using the A tag to sign out, I want to also get the logout link component imported from the same source. And these components are headless, which means you have to also provide a class name right here. So this is now finished. We have our two components added. Nevertheless, we still get errors. And that's because we don't get the user. No, we want to get the user session to be specific. This means above the return statement, we can create a constant, the structured, and this will be equal to get kind server session. Get kind server session is a hook which exposes functions that only run on the server side. And I want to get the get user function, and since this is a promise, I have to also await it. But since this is an async function and this in general is a server component, that's completely fine to do. So now we get our user. This all looks good. Nevertheless, I still get 6 errors as you see right here. And that's because I want to get the user session also in the other async functions. So in the dynamic server stats function, I can also get my user, and I will do the same thing in the dynamic user info function. So I don't get any errors anymore. And if I restart my dev server, then you will see that it now says sign in. Okay, that's what I will do. I will sign in. And as you see, I got redirected to the hosted authentication page provided by Kind. I can sign in with Google, GitHub, or with my email. Now, since I don't have an account yet, I will click on create one and I will continue with Google. And as you see, I got redirected back to my landing page, and now I'm authenticated, Jan Marshall, my email, and here I again see my email with my name. So this worked beautifully, and now we get our user session dynamically, of course, on the server side, and of course this data here, so the stars, the forks, and also this quote from GitHub, all of this data is now dynamic. And I can also show it to you, so if I do a hard refresh, we currently have this amount of stars, and if I start a repo, go back and again do a hard refresh, it instantly updates. And we are currently in a local environment, but even if I deploy to Vercel, everything will work the same way. Let's also quickly build the application. So in the terminal, I can stop my dev server, and inside of here, I will run pnpm run build. This will again create an optimized production build, and it will also pretty much generate static pages, at least if we have any. And as you see here, let me make it a bit bigger, this index page is now a dynamic route, and that's because we have this F, and the F stands for dynamic server rendered on demand. This means at runtime. This not found page is static, and that's again because Next.js is smart and it knows, hey, the not found route, this is like an error route, it does not fetch any data, it does not have any cache headers, nothing like that, it can be static. And this route handler is dynamic because, let's be honest, API routes can't be static. So now we know that Next.js is smart and that everything works, and that's great. But now looking at this website, doesn't it sound a bit stupid to literally SSR everything? So this whole page? Because here's the thing, this section at the top is completely static. The logo is static, the title is static, and this whole section is static. I don't fetch any data inside of here, and I also don't use any dynamic APIs like headers or cookies or anything like that. Then here we have three sections that are dynamic. I fetch data inside of here, I fetch data inside of here, and also in this section. So it makes sense to SSR these three sections. And then this section is again static, meaning I don't fetch any data inside of here. This is static, and this is also static. So looking at this page, we can say, hey, there are sections that have to be rendered dynamically, SSR'd, but there are also sections that don't have to be dynamic. I don't need to fetch data inside of here, and I don't need to fetch data inside of here. Wouldn't it be cool to actually render this section statically and this section statically, while only rendering these three sections dynamically? Good question. How can we implement something like that? Well, the answer is quite simple. It's the answer that you have been waiting for. Partial pre-rendering. So what's exactly partial pre-rendering? Well, partial pre-rendering, or in short PPR, is a rendering strategy that allows you to combine static and dynamic content in the same route. This improves the initial page performance while supporting personalized dynamic data. So looking at this diagram right here, you will see two main sections. We have this violet section and then this blue section. The violet section is static data or data which is revalidated, but it's still cached. And then we have dynamic data, and this is this blue color. So here's the thing, this violet color is now rendered statically. This is like a static shell. And then this blue section, this means the dynamic data, is served dynamically. It's streamed into view. So if we go back to the docs and scroll a bit to the bottom, then we will find this section. So when a user visits a route, the server sends a shell containing the static content, ensuring a fast initial load. So this is this violet section. It's served instantly, and that's because it's pre-rendered on the server as static content. Then as a next step, the shell, this means the static shell, leaves empty spots for the dynamic content that will load in asynchronously. So let's imagine the following. This static data is instantly there, so the user instantly sees everything that is loaded statically. But now this static content will have empty spots, and these empty spots will have like a little loading indicator. And in these empty spots, this means right here, we will stream in the dynamic data. So the last step is that the dynamic holes, empty spots, are streamed in parallel, reducing the overall load time of the page. So this means for our example, we will load this section and the bottom section statically. So it will be rendered statically, it will be pre-rendered on the server and then served instantly with our CDN. These 3 sections will be rendered dynamically. So how exactly can we implement PPR in our application? Good question. Let me show it to you. So again, here we have our async functions. I did not update anything. It's still here as it was a few minutes ago. And as you all know, I have this export default function home. And in this function, I rendered these 3 components or these 3 async functions: the auth section, the dynamic user info section, and then the dynamic server stats. These are our 3 components, our asynchronous components. And how can we now implement PPR inside of here? Well, the first step is to suspend these components. We want to add suspense boundaries. So here I can wrap the auth section in suspense boundaries. Suspense is imported from React, and I will do the same thing also for the other 2 components. We can also add a fallback. I will just say loading ... And if you don't know what suspense is, don't worry, let me explain it quickly. So suspense is actually provided by React, not by Next.js, and it's used to defer rendering parts of your application until some condition is met. In partial pre-rendering, suspense is used to mark dynamic boundaries in your component tree. So now we told Next.js, hey, these 3 sections are dynamic, but the rest is static. But still, currently PPR is not enabled. This means if I go back and do a hard refresh, everything still works and this is still SSR'd. And here in the dynamic server stats function, I can just add a fake delay, let's say 10 seconds. And if I do a hard refresh, I get right here loading ... And once this delay is finished, this means after 10 seconds, my fallback is swapped out for my real data. So this works nicely, but still, this whole page is SSR'd. Sure, it's now faster than before because we suspend these sections, but this is still SSR'd, and that's not what we want. So the last step is to enable PPR, and enabling it is very simple. First of all, you want to open your next.config file. Inside of here, we can get the experimental flag, and here we want to set PPR to incremental. Now this won't work yet, and that's because you want to install the Canary version of Next.js. This means in the terminal, I will run pnpmi next@canary. Now this is like the experimental branch of Next.js. Nevertheless, for example, Vercel uses the Canary branch in production, so it's relatively safe to use. And now there's only one more thing that we have to do, and that's that we want to add this constant, export constant experimental PPR, and we want to set it to true. So I will copy this, and now there are 2 ways, or we can pretty much add this constant in 2 places. We can either do it right here in the page.tsx, or we can do it in the layout. It does not really matter, so I will just add it right here in the layout, and that's because the children will actually adapt the parent. So in this case, since this is now set to true, the page.tsx will also be set automatically to true. This also means if I add an about section here, so /about, it will also adapt this experimental PPR true. If I don't want that, I can set it to false, and then the specific children underneath this flag will also be set to false. But in this case, true is fine because now my page.tsx will also be set to true. And now let's test it out. If I go back and do a hard refresh, everything still works. Is this now rendered statically, the top section and the bottom section? Well, I guess it's time to find out. Let's go back. I will stop my dev server and I will again run pnpm run build to create an optimized production build. Aha, and now we have something interesting. So this isn't a circle, but it's like a half moon. What do you mean by that? Well, now we have 3 options: static, partial pre-render, dynamic. And our index page is now partially pre-rendered. This means pre-rendered as static HTML with dynamic server-streamed content. So again, if we go back, this top section is rendered statically. It's pre-rendered at build time. These dynamic sections are streamed in, and that's why we added these suspense boundaries. We show a fallback while the data is being loaded, and once the data has finished loading, we swap out the fallback for the real data. And then this bottom section is again pre-rendered as static content. And now let's come to the last part of this video, and that's why should you use partial pre-rendering? Now you should already know the answer. We just created this demo. You saw how cool PPR is. Nevertheless, let's look at this diagram quickly. So what's the benefit of using dynamic rendering? Well, it's quite simple. You get fresh data. What's the drawback? Well, you have a big blocking event. If I have a very slow internet connection, I will see a blank screen for 5 seconds. This isn't great. So let's imagine that this whole workflow now takes 5 seconds. So for 5 seconds, I will have a blank screen. What's the benefit of static rendering? Well, the response is instant, almost instant, okay? Because everything is pre-rendered at build time. What's the drawback? I don't get any dynamic rendering, so my data is stale, it's not fresh. It's quick, yes, I get my response instantly, but it does not update. And sure, I can revalidate my data, but it's not the same thing as dynamic rendering. So what's the benefit of using PPR? Well, I get the performance of static rendering. My shell is rendered statically. In this case, this is the top part and the bottom part. They are static, but the dynamic parts are rendered dynamically, which means I still get the benefit of dynamic rendering. So you could pretty much summarize it into the following. PPR is what you get when you combine the power or the performance of static rendering with the power of dynamic rendering. And this is the child, if this makes sense. So PPR is definitely something that you should try out, implement it on your website. Let me know what you think of PPR, and if you're also as excited as I am. I hope you enjoyed this video. I hope you could learn a lot. Thank you, Kind, for making this video possible. And now enjoy your day, and I hope I can see you in the next one. So with that, bye bye.